Hi, everyone. Dr. Eric Westman here. And it's my great pleasure to have today Dr. Stephen Cunnane. Welcome.
Thanks, Eric. It's a pleasure to be here. I'm a professor in the Department of Medicine at the University of Sherbrooke, which is about 4 hours by car north of Boston, east of Montreal, about 2 hours, so just north of Vermont. And I was lumped in the area of brain aging and my interest in ketones, and especially in relation to epilepsy, which I was working on in Toronto, was in relation to brain development. And I learned at an early stage in that sort of line of inquiry that ketones are actually physiologically essential for early brain development. And the fact that we're trying to use them therapeutically in adults and perhaps in kids too is, I think, an offshoot. But underneath that, there's a physiological need for them in the brain during early development that we have pretty much lost track of. And I keep promising myself to sequester myself for a few weeks and get a paper written on this, because I've got all the references and most people don't really realize the extent to which they're important for early brain development. So I thought, if they're important for early brain development, perhaps they're important for brain aging as well. And, it doesn't get more exploratory than that, but it has gone forward. And that's pretty hard to establish. But what has been shown in two different studies is that at birth, a third of the brain's energy requirements are provided by ketones, a third. That's two separate independent studies. So it suggests there's not enough glucose in the system to feed the brain to meet its requirements at that stage. And that requirement for ketones goes down. It's supplied by medium-chain triglycerides in mother's milk. In women or infants that are not on mother's milk, they're still provided from the body fat stores that a normal term infant has. So it becomes more of a challenge for a premature infant or a low birth weight infant to meet its brain energy requirements and grow normally. And those are the babies that have the highest risk of basically neurodegenerative problems or delayed neural development, I should say. Well, I was studying omega-3 fatty acid metabolism in the brain, and the parent of the omega-3s is called alphalinolenic acid. And we had a technique to study it with what's called a stable isotope. So it's not radioactive, but it's got a marker on it that allows you to see how much of that stuff you give has transformed to the end product you're interested in, which was docosahexaenoic acid, DHA, in the brain. And the anecdote is that we saw the conversion of alpha-linolenic acid to DHA. That was novel. We were trying to study it in living animals at the time, which was novel. And what blew me out completely was the fact that most of that tracer ended up in cholesterol and palmitic acid and oleic acid in the brain and not in DHA at all. So there was the expected conversion, but there was this whole area that most of the tracer was actually going elsewhere. And I thought, how can that be possible? What's the biology, the intermediary metabolism? And the ketones are produced from alpha-linolenic acid is in soybean oil, it's in flaxseed oil, it's in anything green that you can eat, actually, but the oils. And it's got 3 double bonds that are relatively easily beta oxidized, not peroxidized, but beta oxidized, which means broken down to make energy. And a lot of the carbon that is broken down by that process ends up being recruited into lipid synthesis through ketones. And in fact, ketones supply about 90% of the carbon that you need to make lipids in a newborn as well.
So a child needs ketones to make cholesterol in the brain.
Yes.